Right, paper 1, question 9, part A. Complete the table below showing the height of the ramp at the indicated points. So the formula or function you're given is h is equal to x squared minus 6x plus 9. Values for h are between 0 and 5. So h equals x squared minus 6x plus 9. Then h is 0 will be 0 squared minus 6 times 0 plus 9. So 9, h1 is equal to 1 squared minus 6 times 1 plus 9. 1 squared is 1, minus 6 times 1 is minus 6, plus 9 is 4. h2 is equal to 2 squared minus 6 times 2 plus 9. 2 squared is 4, minus 12 plus 9. 4 and 12 is 4 and 9 times 13, take away 12 is 1. h of 3 is equal to 3 squared minus 6 times 3 plus 9. 3 squared is 9 minus 18 plus 9. 9 9 is 18, take away 18 is 0. h of 4 will be 4 squared minus 6 times 4 plus 9. 4 is 16, 6 4 is 24, plus 9, 16 add 9 is 25, take away 24 is 1, and h of 5 is 5 squared minus 6 times 5 plus 9, 5 5 is 25, 6 5 is 30, plus 9, 25, add 9 is 34, take away 30 is 4. So when x is 0, hx is 9, x is 1, hx 4, when x is 2, hx 1, when x is 3, hx 0, when x is 4, hx is 1, and when x is 5, hx 4, using this formula. Choose the coordinates with A as origin, show the curved surface below. So if A is origin, that means it's 0 0. Next point is 0 9. Second point is 1 4. Third point is 2 1. Fourth point is 3 0. Then it's 4 1 again. And 5 4. Then I join up my plots on the table. And since it's curved bottom, and that is h of x. Then look at part C. To enable a snowboarder to get a good air, i.e. to get off the ground, the air off jump ramp, the slope. To get high on the air off jump ramp, the slope take-off point should be almost vertical. Find dx dh. So if h is equal to x squared minus 6x plus 9, dx dh, dx, sorry, so differentiating h with respect to x, so down my power, so 2x, 1 away from my power, so 1, minus 6x, that's a 1 there that we never write down, so 1 times x is 6. 1, take away 1 is 0, so knocks the x out. And 9 doesn't have an x, so I just ignore it. So h dx, 2x minus 6. Does the ramp meet the slope criteria? Give a reason for your answer. So it says it should be almost vertical. So 2x minus 6, so put it to 0, sorry, let x be 0, so it's starting off 2 times 0 minus 6, so it's equal to minus 6. I do tan minus 6. .81 degrees. So the answer is yes. as it is close to a 90-degree angle. Then part D, the slope of the run-in downward section leading to the ramp which allows snowboarders to build up speed is 1/2. To achieve a smooth transition between the two, the run-in is tangential to the curved surface area of the ramp. Find the coordinates of the point at which the run-in is a tangent to the ramp. So what this means is that dH dx equal to 1/2. So your slope's 1/2. So you worked out dH dx is 2x minus 6, so equal that to 1/2. Want to deal with whole numbers, I'm just going to times this by 2. 4x minus 12 equals 1. 4x minus 12 equals 1. So 4x equals 1 plus 12. 4x equals 13. X is equal to 13 over 2. Then I need to get y, or my h of x. So my formula was h of x equals x squared minus 6x plus 9. So found 13 over 2 in for x. 13 over 2 squared minus 6 times 13 over 2 plus 9. I'll put this to the calculator. 13 over 2 all to be squared minus 6 times 13 over 2 plus 9 is equal to 49 over 4. So h of x equals 49 over 4. Mistake, x here is 13 over 4. Here it should be 13 over 4. Here it should be 13 over 4. Then we change, we work it out. Equal to 1/16. So your point is 13 over 4, comma 1/16. We'll look at the decimal where they're actually at. 1/16 is 0.0625, and 13 over 4 is at 3.25. 3.25, 0.0625. So if I look over my graph here, it's 3.25, so 3.25, 0.06. You're not even up one bit of a square, you're literally just there. And that's point 13 over 4, 1/16. It's just here coming out. Then on the diagram, show the line that represents the run-in. So you're running in just to your point here and has a slope of 1/2. It's just going to be this line here. So that's your in run. And the final bit, it says find the equation of the line that represents the run-in. So equation line formula from Nautilus, y minus y1 equals m bracket x minus x1. So m is the slope. We know from our question it's 1/2. x1 and y1 are a point. The point we have on our run-in, we worked out just above here. It's 13 over 4 and 1/16. So that's our x1, y1. So it's y minus 1/16 equals 1/2 bracket x minus x1, which is 13 over 4. Full marks been given from here, but we'll work it out. Y minus 1/16 is equal 1/2 times x, so it's x over 2 minus top by top, bottom by bottom, so 13 over 8. My three fractions, 16, 2 and 8, are all factors of 16. So if I times by 16, I'll get whole numbers. So it'll be 16y minus 1 is equal to 8x. 2 goes into 16 8 times. Minus 2 times 13, which is 26. 8x minus 16y minus 26 plus 1 will equal 0. 8x minus 16y minus 25 equals 0. So your equation is 8x minus 16y. You can even equal it to 25 if you want. The equation of the running is 8x minus 16y is equal to 25.